Okay, so um, I didn't, I didn't spend a whole lot of time rehearsing this, but I'll try not to everyone's, take up everyone's day, but sort of go over the background of how this started. And the topic that I wanted to share has to do with is what I'm calling which came first. Um, so the issue, to kind of paint a picture, there's been a few, there's been a number of issues in the past related to how to get how to get your wallet transactions in the right order, or at least an order that makes sense to a user. So, and this, what's interesting is like this particular issue is a couple years old, and the BDK library has gone through a number of iterations, changes since then. But it seems like this issue keeps coming up time and again. There's another one that I keep coming back to. It should be easy to get the transactions in canonical order. And just some high level ideas. Lloyd mentions they could be ordered by first seen, seems like a logical approach. But going back to this crypto quick issue, um, this kind of illustrates it's hard to tell from this screenshot, but if you can imagine, so what he's saying is multiple transactions confirmed in the same block. And uh, I'm assuming, I think I did some digging, and you can go to mempools.space and look up these transactions. But um, the way I understand this is, say you received some funds, 100,000 Sats in one payment, one UTXO, and then you make a series of you make a series of payments, like one at a time, and you can see the amounts. I guess if you received 100K Sats first, then the next lowest amount would be like an outgoing payment. And then you take the change and roll that into the next payment. So it'd be something like, I guess, 96, right? You get the idea. But the problem is these are sort of they're sort of jumbled up. You can't tell which one came first. So this is an important from a user perspective. Like if you're just scrolling through a list of transactions, I mean, we can all relate to this, whether it's like your bank statement or some crypto wallet on a mobile device. You would expect to see them in something resembling chronological order, or um, the correct term would be like topological order. So, which basically means you you can't send something before you first received it. So that's uh, should be fairly self-explanatory. And it shouldn't matter if like the receive was on the bottom or the top. You could sort of it could go either way, chronological or like reverse chronological. But the point is that they're internally consistent. You can see why this would be confusing if having them not in the right order. Um, it's just a poor UX. And so there's other reasons why um, this would be important. Like it's actually matters for consensus reasons, because a Bitcoin node um, is going to expect to validate transactions in a block sequentially, like from the top down, right? Like a node doesn't want to have to scan through all the transactions in a block in order to validate an earlier one. So transactions need to be valid in the order that they appear in a block. And to be valid, what that means is basically the UTXO that a transaction is spending needs to be on chain or part of the UTXO set and currently unspent. Um, so there's other sort of real world implications to this that could have you know costly consequences. And I didn't fully think of this when I was putting the talk together, but I was listening to a talk from BTC++ online, and this say you have like some custom logic for constructing block templates, then you know the the consequence of misordering your transactions could be the opportunity cost of mining an invalid block, basically. So that sort of paints the picture. And so I wanted to jump into a little bit of a coding demo, and we can sort of take this in steps. Um, so I thought this would be somewhat more engaging than just talking at you. So hopefully everyone can see that. Um, so say we have a pool of transactions represented by this dependency graph. So here I've drawn a dependency graph. You can imagine time. If you imagine time pointing sort of down the screen, we have A as an ancestor transaction. B spends A, E spends D, etc. So uh, you can imagine a possible grouping of the transactions like this: A and B, C, D, and E, and then F on its own. But there's other ways. There's other ways you could order this. Like I don't know if you started with E, D, A, C, and then B on its own, F on its own, or you could start with similarly F, D, A, C, something like that. So there's maybe not one correct right way, but potentially multiple valid ways to group these. Um, so if you think about sort of what the intuitively, what did I do here? I sort of picked one transaction that is like a descendant, and then looked for any of its ancestors. So say I started with E, I would want to pick up all of the ancestors of E. So D, A, and I want to visit them like exhaustively, D, A, C. And I also only want to include each transaction once, so they're sort of discrete and non-overlapping. So the idea is to come up with an algorithm. Basically, the idea of this demo is to get you thinking in terms of algorithms. So how could we, given any pool, potentially arbitrarily complex pool of transactions, how can we apply a systematic approach to get these in the right order? So instead of actually trying to code, I can uh, check out the next. Okay, so I wrote this in the form of a Rust module because that's what I spend most days doing. So you don't have to understand every line of what's going on here. But the first step, hopefully everyone can still see this. The first step, what I'm calling level 1, is to audit the pool. So I came up with a new type, which is the package selector, and it groups transactions by entries. And I have a few constructors. And basically in the constructor, you pass in a list of transactions. And first thing it's going to do is insert them all into a new empty TX graph. And then map each transaction to an entry with the thing to notice here about entries has ancestor and descendant sets. And then this other step is to populate the ancestor descendant sets with this function I'm calling setLinks. And the implementation of this setLinks function, it says fill in the ancestor and descendant sets for all entries. Note that each set includes the entry itself. And what's interesting is this code is actually deceptively simple, where it's not, I mean, you can see what's going on. We just get a mutable reference to the ancestor set and fill it with this call to walk ancestors starting from this entry's TXID. And then we do the same thing for the descendants by walking the descendants. Someone have a question or no? So, right, I mentioned this is, it looks surprisingly simple, but the real magic happens if we were to dive into this walk ancestors function, which maybe a little later on we can come back to this if people are interested to actually look at the implementation of how we're traversing the TX graph. But the idea of this code was to try and come up with a solution using sort of the high level APIs that we already have available. So then in the main function, the whole point of level 1 is just to audit the pool. And so I should be able to run this. And then you can see sort of the dummy transactions in there, but that's not important. What the thing to notice is every entry is keyed by its transaction ID and has the ancestor descendant sets populated. So I had 3 transactions. You can see that the TXID appears in each of the ancestor descendant sets. You notice if a transaction spends a previous transaction, that this should also be one of the ancestors of this entry. So that logically makes sense. So then we can go on to phase 2. Okay, I kind of just spoiled the surprise, but so the second part, the only thing I've added is the select function. So if we go back down to the demo, the only new thing here is I have a new function where the package selector is actually going to select the entries into packages. So the new thing here is select, and this is the sort of algorithm that I laid out at the beginning, is to first find, if we go back to our picture, find the last descendants, the children that have no descendants of their own. But if we read this step by step, select groups of transactions into non-overlapping packages, where a package is defined as a single TX and all of its not yet selected ancestors. And then I have here that we create packages are created and therefore returned in the order of chain position. So I use chain position just for good measure, which would allow us to sort, um, which would give us a sorting between separate unrelated packages. So chain position would be either the confirmation height and time of a confirmed TX or the latest time that it was seen in the mempool. So if everything has a different chain position, then they could be we can easily order them. But say hypothetically, if in the case of the same block, a chain of dependent TXs in the same block, then how do we, we need like a more granular approach. So if there's a tie, all way tie between chain position, then what's the logic for breaking the tie? And what I'm proposing with package selector is to use basically the ancestry. So the steps again are to locate the terminal children. That's probably not the best term for it, but like the last descendant, the final descendant, or the last unspent descendant in the pool, and then sort the children by chain position, and then for each uh, child, we're going to create a package by just including everything in the ancestor set, and we make sure to only visit every entry once, and then sort of the kicker is in order to sort the entries within a package, um, the little shortcut we'll use is sort by ancestor count or the length of the ancestor set. Um, right, so hopefully that makes sense. And then the return value is, there's nothing glamorous about the return value. It's just a vector of vectors. So we read this as a collection of packages, collection of groups. So then to show off level two, our expectation then is that, so these three entries are related where one spends the previous one. Maybe that wasn't clear. But so what we expect is one single package and they should be in the correct order. Okay, so that's really all that's going on here. So we should be able to run this again. And hopefully you can see we just printed out each of the TX IDs as they occurred, and then the package returns them in the correct order. So this is a topologically valid order, meaning ancestors have to appear before children. So that's it for the package selector. Now, this is sort of I want to like sort of preface this or mention a disclaimer that, you might wonder, why doesn't this exist in BDK already? And I'm not necessarily proposing or advocating that we like implement the code that I have here. This is really just to illustrate a point and a way that you could approach it. So what's interesting is, again, I used the just public APIs to accomplish this, but actually thinking more about it, I feel that there's probably a smarter solution to this that is closer to what already exists in BDK. And what I'm thinking of specifically is the new canonicalization routine that was introduced um, around the time of the new 1.0 APIs. And the without going too deeply into detail, the canonicalization algorithm in TXGraph today, it uses this very notion of traversing ancestors and descendants of the TX graph. So, but I couldn't help, you know, trying to figure out if this issue was actually solved by canonicalizing the TX graph. And I think it's my opinion is that it's very nearly perfect the way BDK works now, except for this small sort of edge case where if a group of TXs and it's in the same package all share the same chain position, then then how would we handle that? So just to jump back to the code briefly, I wrote I actually wrote a little bit more involved, like two more unit tests. So here was the original example. So this tests um, the example from the beginning, and then there was another one where I want to chain some number of transactions where each one spends the output of the previous one. And then this test is saying, um, so we're going to shuffle them before we pass them to the selector. And then in the test, we assert that it came back in one package. So without spending too much time on this to sort of convince ourselves that this actually works. See the test pass. And actually, I shared this repo um, publicly if anyone wants to look at the code. I just called it package selector. So the code's on GitHub if anyone wants to see. Okay, just looking at my notes. I heard a noise. Was that a comment? Right, so that was the demo. And then a couple of things we could touch on is there's a method in BDK wallet, this method transaction sort by. And it seems like this would work because you can even pass in a comparison function. So you can already sort by the most logical thing to do would be sort by chain position, like I already mentioned. But the sort of catch, the caveat is just by comparing two wallet TXs, can't necessarily tell you can't tell you which one came first in terms of the ancestor descendants. So um, so yeah, I guess I don't actually have the answer to this, but I thought it would be good to outline the problem and see if other people come up with solutions. Um, so I don't know if I missed anything, but I tried to somewhat breeze through it. But yeah, that's nothing else comes to mind immediately. So that's about all. That's everything I had prepared. So if there's anything else you guys want to touch on while we have time, I can do that.